Okay, so our first array question is to remove duplicates from a sorted array. So given an integer array, sorted in non-descending order, remove the duplicates in place such that each unique element appears only once. Okay, so what does that look like? So here, 1, 1, 2, they just bring the 2 over here basically, and then just get rid of this 1. So they just basically swap it. In this example, uh, they they take out all the duplicates, and then whatever's after here, I guess doesn't matter. Yeah, it says here, it does not matter what you leave beyond the first k unique elements, okay? So, okay. So how are we going to do this? So given this array, we want to end up with 0, 1, 2, 2, 3, 4, right? And then whatever, whatever, whatever. So, how are we going to do this? So it's very important to realize that it's going to be important for us to keep track as we're iterating through this array. We want to basically keep track of our last unique element that we have discovered as we're iterating through it, right? So when we start off, we're going to set it equal to 0. So this will be our last unique index, right? We're going to keep track of the index of the last unique element that we find. So here it's going to start at 0, and we're going to start a loop at I equals 1. So at the second element, second index, we're going to start a counter, I equals 1. We're going to basically check if the element at u and the element at I are the same. And if they are the same, then we're not going to do anything. We don't care. We're only looking for unique elements, right? So we're just going to increment I when that happens and check if they're the same. So in this case, they're not the same. The element at u and the element at I, they're not the same. So what we're going to do is, what we want to do is set the index at u plus 1. So right now u is at 0, at index 0. We want to set the index 0 plus 1, so this element, equal to our new element that we found. This is our new unique element that we have found in the array as we're iterating through it. So we're just going to set this one equal to that element, and then we're going to increment u as well as increment I. So now we're keeping track of this new element that we found. It's keeping track of its index, right? So now we compare these two, the elements at u and I. So are they the same? They are the same. We don't care. We're just going to increment I. Forget anything happened. Do the same thing. 1 and 1. They're both the same. We don't care. Increment I again. So in this case, the elements at u and I are different, right? So we're going to do the same thing. We set the index at u, so at this case it's 1, plus 1, so 2, or index 2, the one right after it, is going to equal this element. So we just set the element right after this u equal to the new number that we found, right? Now we're going to increment our u to keep track of this new element that we found, and we're going to increment I as well. And we do the same thing, check if they're the same. In this case they are the same, doesn't matter. Increment I. So in this case they are not the same, 2 and 3. So we're going to do the same thing, set the element right after u equal to the new element that we found, right? So set that equal to 3, and we're going to increment u to keep track of this new element, and increment I as well. Check if these two are the same now. 3 and 3, they are the same, doesn't matter. Only increment I. And then for our last element, 4, we check if these two are the same, and they are not the same. So we're just going to set the element right after our u equal to the new element that we found, and store that here. So in this case, what we have here is our u is going to equal 4. Not because of this element. This is the element at u, but our index is 4, right? So if we want to return the number of unique elements, because in this case it's saying to output 2, which is the number of unique elements that we found, or in this case 5, because it's 0, 1, 2, 3, 4. These are 5 elements, 5 unique elements. What we have to do is just return our u plus 1, right? Because if we're at index u, and this is storing our last unique element, we just return the u plus 1, and that will give us the number of unique elements that we have stored, right? So that's basically the ideology behind this algorithm. So how are we going to implement it? So, as I stated earlier, we're going to have a last unique index element, and it's going to start at 0. So it's going to start at the first element of the array. And then we're going to iterate through the array, starting at the first or the second index, right? So index 1, second index. I is less than nums.length. So we're just going to iterate through the array and check if the nums at our last unique index is equal to the element that we just iterated into. So the number that we're on, we're going to check if they're the same, right? Oh wait, this should be a if statement, right? So check if they're the same, and if they are the same, or if they're not the same, we're only going to care if they're not the same. That's the only time we do anything. If they're not the same, all we do is set the nums at our last unique index plus 1 equal to nums I, right? So set the element right after our uTracker, set the element right after equal to the new element that we found, and then we also want to increment our last unique index, right? So that it keeps track of the element that we just found. And as we're doing that, this is going to keep doing it until it reaches this point, and then once we finish the for loop, we just return our last unique index plus 1. And it's that simple, right? So this should work perfectly fine. Yeah. So as for time complexity and space complexity of this algorithm, what would we say it is? So since we are only iterating through the loop, or through the array, only one time, like we're just going from the start to the finish in place, and we're doing all of the swaps, all of our new elements are being swapped in place. Like we're not using any extra space as well. So granted that n is the number of elements in the array, our time complexity is going to be O of n, because our algorithm is just going to iterate n times, which n is the length of the array that we're using. It's going to iterate n times, right? And our space complexity is O of 1 as is O of 1, as we are the only extra space that we're using, the only space at all that we're allocating is this. That's it. And that's all it would be. So time complexity is O of n and space complexity is O of 1. If we, for example, created a whole new array and then kept track of the elements like that, then our space complexity would be O of n at that point. But since we are doing this in place and we're not making a completely different array to make this easier for us, since we're only using our one counter that we have that keeps track of our last unique index, this algorithm has a space complexity of O of 1.
If you like this video, make sure to check out my course on Udemy where I go over how to approach and solve LeetCode's top interview questions in Java. This will help you get more comfortable applying concepts like arrays, strings, linked lists, binary trees, dynamic programming, object design, and many other concepts in order to solve problems effectively and ace your interviews. So if you're interested in it, feel free to check it out through the link in the description. And with that being said, I hope you guys have a good rest of your day, and I'll see you in the next video.